Hello, this is Dennis Allison, and I'm hosting EE380 today. We're recording this on October 26th. Our speaker is Andrew Gelman, and he's a professor at Cornell, and he is a statistician and has been doing some very interesting work in the area of the predictions people have been making about the election. And with that, it's yours. You go on.
It's a privilege to be speaking to an EE class. I went to MIT many years ago, and I was a physics and math major. And at MIT, if you studied physics, you were considered to have your head in the clouds. So a physicist at MIT, it would be like studying poetry or basket weaving somewhere else. Like the students would all ask, like my friends would be like, why are you studying physics? Don't you want to get a real job? Like that kind of thing. So as I said, to be actually asked to speak to an EE class, I feel like I've actually made it and I've succeeded. I've been involved in election forecasting for a long time. Not always using the polls though. So back in the early 90s, my colleague and I had a research project which was about why are pre-election polls so variable when elections are so predictable. And that was based on a phenomenon that was well known to political scientists, but not that well known to journalists, which was that although the election polls would jump around, political scientists typically had a good idea of who would win the election based on information a year out, like based on the state of the economy, economic trends, incumbency, results in previous elections, and so forth. So in order to write our research paper, we had to demonstrate that elections could be predicted. So we did a simple election prediction model predicting that Bill Clinton would beat George H.W. Bush. There was nothing special about what we did. We took a bunch of existing models and kind of put them together. The only innovation of what we did was we allowed for uncertainty in each of the 50 states. And before we came along, there have been some nationwide predictions which didn't get the Electoral College. And then there were some state-by-state predictions, but the state-by-state predictions didn't account for the correlations between the states. So we did that. It was not a wonderful prediction. For example, we said that we expected Bill Clinton to win Texas. But Bill Clinton didn't do that well in Texas. We did not think that Bill Clinton was going to win Texas, but our forecast was based on information in our model. And one piece of information in our model is that Bill Clinton was a Southerner and Southerners did better in Southern states. It didn't really account for an interaction, and it didn't account for increasing political polarization. So where you're from is just less important than it used to be. It's much more important which party you are. Our model would have done better had it used pre-election polls. Like polls from Texas would have told us that George H.W. Bush was favored in Texas. And other southern states, not just Texas, which of course is also Bush's home state. But we didn't use the polls on purpose because we were trying to demonstrate that elections could be approximately forecast months ahead of time. However, in the years since, journalists have been very interested in poll aggregation and election forecasting. This particular election, 2020, I was contacted a few months ago, I guess maybe it was February, by a data journalist for The Economist magazine. They wanted to build an election forecasting model combining what I did before, combining state and national forecasts, but also combining pre-election polls. And it was a technical challenge. So they asked if I could help out. And so I and a political science student helped them make their forecast. And the technical challenge is that we have an election that's happening in November. And to predict the election, we have information like presidential approval, different measures of the state of the economy, incumbency. We have a regression type model trained on past elections. Also the relative positions of the 50 states in previous elections, because usually things are pretty stable from one election to the next. That is aiming at election day, but then we also have polls, but a poll is a snapshot, not a forecast. So we have a series of polls up to, if it's currently day X, We have polls all the way up to day X and nothing between day X and the election day. The way we connect the polls to election day is that we have a latent time series model on the 50-dimensional vector, which is the positions of the 50 states. It was literally Joe Biden's support among people who support either Biden or Trump in each of the 50 states on each day between now and election day, and all the previous days too. The polls are a noisy signal of that. So every poll has sampling error. That's the balls from the urn sampling error that you learn in your statistics or probability classes. Also non-sampling error. Surveys have very high non-response rates. And we empirically, it turns out that the empirical error of election polls is about twice the stated margin of error. And there are different sources of non-response. There are different sources of non-sampling error. There's different polling houses. Some polling houses favor the Democrats, some favor the Republicans. This is not, by the way, mostly attributed. I don't think this is mostly attributed to partisanship. Like, I don't think that it's like Fox News is very partisan, but Fox News polling is just a pollster. Pollsters try to be accurate. The reason why pollsters don't make money off, most pollsters don't make money off of opinion questions like, who do you plan to vote for president? Pollsters mostly make money off of questions like, what brand of refrigerator are you trying to buy? What's your favorite internet browser? What would it take you to switch cable TV companies? They also throw in some political questions because then they can get in the news. They're advertising. They're like loss leaders. So if you're a pollster, your motivation, I mean, Fox News has motivations, but they hire professional pollsters. And if you're a professional pollster, you want to get the most accurate answer because it's your rep on the line. And what you're selling to the sellers of dishwasher soap and consumer electronics is not your partisanship. You're selling your polling acumen and your accuracy. So that's kind of, there's an economic reason why we think polls will be not too far off. That said, why are pollsters not all the same? Why do some pollsters have a positive house effect and some have a negative house effect? Well, those effects are small. With rare exceptions, the polls that favor Biden are maybe 1% favoring Biden more than Trump, and the polls that favor Trump might be favoring Trump 1% more than the average poll. They're fairly small effects. They occur because different pollsters use different methods. You might as well ask, how come different car companies have cars that have different gas mileage? Because they have different factories, they have different engineers. They're always trying to improve their cars or their polls. They're always coming up with new ideas, so they're not all doing the exact same thing. So you need to account for that. In addition, there are these larger non-response biases that we're concerned about, like things like what happened in Minnesota, Michigan, and Wisconsin in 2016, when the state polls did not adjust for, I believe many of the state polls did not adjust for education. Surveys tend to have too many well-educated voters. Too many well-educated people respond to polls, and you have to downweight them if you want to get a more accurate answer. So that wasn't done. Well, now they know to adjust for that, but there's always something else. So there's always potentially large biases. There's also potentially national biases in the polls that may be just systematically Biden supporters may be more or less likely to be responding to the polls than Trump supporters. And then there are uncertainties at the other end, like voter turnout and possible changes in opinion. So because of that, for many months, we've forecast that Biden would get about 54% of the two-party vote. It's been a very stable forecast for two reasons. One, the polls have not moved very much. Three reasons. One, the polls have not moved very much. Two, even if the polls move a little bit, there's kind of a lot of other polls. So it takes, like when you're averaging a bunch of information, one more piece of information won't do that much. One poll is not going to shift our forecast a lot. A series of polls would indicate that there's a time series shift, but you would need that information. And then the third piece of information, the third reason why it hasn't jumped around that much is that sometimes the reason why polls move is what we call differential non-response. So after the Republican convention, you might get Republicans fired up and more likely to respond to polls. So the polls will show a Republican shift. However, you'll also see more Republicans in the poll themselves. And so you can adjust for that. because we don't think that there's this big shift in party allegiance after the convention. We think it's non-response. So we adjust for all these things. We end up saying we think Biden's going to get about 54% of the two-party vote, but with uncertainty. Maybe it could be, we're pretty sure it's going to be between 51% and 57%. Don't quote me on the exact number. You can go to economist.com and see what we have, but roughly that. If Biden gets 51% of the vote, he might lose the election because of the distribution of the votes and the electoral college system. Okay, that's all background. So what I want to talk about, my title is How Can We Understand and Evaluate Election Forecasts? Now, there is evaluating forecasts, probabilistic forecasts, there's a big literature on this. Going back at least to 1950, when there was a paper by in the Monthly Weather Review, I believe it was, by Breyer, which is where the Breyer score comes from, which is something that's used in probability forecasting. There's other things that are done. A lot of literature on calibration of forecasts. If you say something is supposed to occur 80% of the time, you can look at all the forecasts. And if you've made 100 such forecasts, it should happen 80 times out of 100. Forecasts can be overconfident or underconfident. So example of an overconfident forecast is I give you a bunch of 95% intervals, and it turns out that they're only correct 75% of the time. So you are overconfident. That's very common. A lot of psychology studies have shown that if you ask people to give subjective 95% intervals, you have an uncertain quantity, like what the election's going to be, whatever, ask people to give an upper and a lower bound and say, we want there to be a 95% chance the truth lies within that bound. Empirically, people tend to give intervals that only have about 2/3 coverage. It depends on the question, but that's just the way it is. People are overconfident. You can also be underconfident. What would be an example of underconfidence? Suppose, well, one thing would be my 95% intervals contain the true value 99% of the time. That's sort of maybe hard to see. Let me give you a cleaner example. Suppose I now ask you to give me 50% intervals. We can do that. Like our forecast, here's a 50% interval. It's an hour, right? We think there's a 50% chance the true value is going to fall in this interval. What if I create 50% intervals, because that's my job, and it turns out that 75% of them contain the true value? Well, the funny thing, then I'm underconfident. I'm not providing the precision that I could be providing to my customers. I'm not doing them a good service. On the other hand, I might look pretty good because you say, look, I'm right 75% of the time. If you give 50% intervals that are wrong 50% of the time, then half the time it fell outside your interval. Then you have to explain, oh, no, it's 50% interval, whatever. It's difficult. So my point is that communication involves give and take. It involves incentives. It involves goals. There's no kind of reason ahead of time why people would think their intervals would be calibrated. So that's why we talk about external calibration. If somebody is in the business of producing intervals, we can take their intervals and check their external calibration. So for example, the website 538.com does sports forecasting, and they collected all the sports forecasts I've ever made, and they found that their 80% intervals contain the true value 80% of the time, like things like that, very highly calibrated. Worked very well. And sports betting, like there's a lot of people who do that. So there are people who bet on sports, who finance sports bets, and they're always collecting these bets and checking that the stated odds are appropriate. Sometimes there are bad odds out there, and the bookies can get burned. But typically they're pretty good because there's a lot of economic motivation to calibrate the sports betting odds. Political betting is much different. There are thousands of sporting events, and each one is kind of independent of all the others. They have a World Series game, then there's another World Series game. Each has its own odds. There are not 50 presidential elections in a year. There's one presidential election. There's 50 little elections, but if Joe Biden does better than expected in Alabama, he'll probably do better than expected in Mississippi. He'll probably do better than expected in Alaska. He'll probably do better than expected everywhere. Not everywhere for sure, but if you outperform, you can make graphs of this. And basically, if you outperform, then you'd expect to be outperforming in other places too. So I cannot evaluate my state level, if I want to evaluate my state level predictions based on calibration, I can do that, but those evaluations will be correlated. So it's strictly, if I wanted to think statistically, I'd need to evaluate them using a multi-level model. Or speaking casually, it's not n equals 50, it's n equals 1 for each election. So what is n? Well, in the title of my talk, I wrote n equals 15. That's an arbitrary number. That's the number of elections in the last 60 years. I'm not going to go back to 1787 and say what predicted George Washington's stunning victory in the unopposed election in 17, that when he was elected in 1788, right? That doesn't make any sense. I'm not even going to use it to predict Abraham Lincoln's election or Herbert Hoover's election. The issues were different back then. The two parties had different roles. There are many periods in American history where the parties were not even close to balanced. There's a period of many decades in the 1800s and early 1900s when the Republicans were dominant, and where Democrats didn't necessarily mind if they didn't get the presidency because they had Tammany Hall in New York City. They could make more money that way than by having a president. It was a different era. So maybe there are 15 elections, but maybe not even 15, because 60 years ago, we did not have the level of polarization that we have now. Candidates Richard Nixon was considered a very conservative right-wing Republican, big anti-communist, he hung out with Joe McCarthy, all that stuff. Nonetheless, in the context of today, Nixon would be considered bipartisan, that he worked with a Democratic Congress. Jimmy Carter was a political moderate. He was liberal on some issues and conservative on others. Reagan was very conservative. Ronald Reagan was always ideological as a politician. That was one of his selling points, was his ideological sincerity. But although he was extremely ideological, the country was still, many of the voters were still split between the parties. And the political parties in Congress were more diverse. And there were moderate Republicans and and conservative Democrats in Congress. Things have changed. So you could say we don't have 15 past elections. We only have 6 past elections, something like that are in the modern era. So we cannot evaluate the calibration of forecasts. So that means, okay, this is engineering class, right? So it's not civil engineering, so I apologize, but you're building a bridge, right? And you can't, what's the probability the bridge is going to fail? Well, you want it to be pretty low, right? Well, you're not going to find that out by building 1 million bridge and finding out that only 4 of them failed. And so that you actually have to have a model of the bridge. Ultimately, you have to see, does your model make sense? That's right. So that's what we're doing here. So that's what I wanted to talk about. How can we try to understand a forecast? And I'll give you two examples, and I'm first going to briefly talk about some problems with our own forecast, and then I'll talk about some issues with the forecast on 538. So okay, this is The Economist. This is our election forecast. We give Joe Biden a 94% chance of winning the Electoral College. We estimate he'll get 350. I should say, someone asked me about this. So we estimate he's going to get between about 300 and 400 electoral votes, probably. I guess our 95% interval is our 95% interval for him is 237 to 421, and he needs at least 270. So we're saying losing is still within the 95% predictive interval for him. He could lose, or he could crush. We don't think he's going to get 500 electoral votes. There's I should say, there's some funny thing about the Electoral College, because there's also, they count the electoral votes of Maine and New Hampshire, Maine and Nebraska, slightly different than the other states. So our estimated electoral vote forecast might be off by 1 or 2 because of that. But not really a big deal, but perhaps I should mention it. This is how the forecast has changed over time. And if you look at the time series, you see that there was a point in April when they were considered even. There weren't really polls back in April. That's based on the fundamentals-based forecast. So back in April, the economy had yet to crash. And so back in April, it looked like it was kind of even money election. Then since then, the economy has gone downhill. Biden's chances have improved slightly in the past few weeks. And it's sort of hard to see that, but if you can see a little bit of a trend, and that has to do with a combination of improving polls for Biden and also that we're closer to the election, and so there's sort of less time for there to be changes. Given how Biden has such a big lead in the polls, you might wonder why we don't think there's 100% chance he'll win. But as I said, there could be polling errors at the national level that could be causing that. I'm going to scroll down. I'm going to scroll down here. We have a chance of winning each state. Key states, the popular vote. Okay, this is our estimate and 95% predictive interval for his share of his support among the voters. So our estimate is that he was more popular than Trump, we think, in April, but that Biden's more popular than before. We're not counting any third-party votes here. We find our prediction is that there's a 95% chance he'll get more than half the vote. But again, getting more than half the vote won't necessarily win the election for him. I like this particular graph because not only does it have our estimate, it has the polls on it. And it's really nice when you put stuff online because people find things. So someone looked at this graph. Now let's see. I'm going to blow up part of it here. Okay, I'm going to blow up what's been happening since October. Sorry. Okay, so notice that since October, there's been almost all the blue dot. This is Biden support and this is Trump support. Every dot's represented twice. It's symmetric. They add up to 100% by construction. So let's just look at Biden support. Every poll, all but 2 polls since October are above the line. So somebody sent me an email and said, why is that? This seems weird. Some of the polls are above the 95% interval. They're all above. Like, what's going wrong with your model? And well, I'll just say there's always a possibility that we have a bug in our code and that we're like not using the polls right. So let me say that could be. But I talked to my collaborator and he made a couple points. So the first point is that the dots are not as much higher than the line as you might think. Because yes, the highest dots are way up here. The lowest dots are down there. If you look at the average of the dots, they're around here. It's hard to see in the scale, but they're about 1 percentage point higher than the line. So it's not as much as you'd think. There's like kind of visual pattern where you end up looking at the top of the range rather than the middle. But then he said the other thing is that the polls that don't correct for party identification we're showing Biden looking better than he is because Trump supporters are kind of discouraged and not responding to the polls so much. And that's going to be explaining some of that. The other thing is that these are national polls, and then they're also state polls. And apparently, for some reason, Biden's looking better in the national polls than the state polls, and we have separate graphs for each state with that. Now, I'm sharing you all this not because you're going to suddenly be an expert on polling, and indeed, like I might be getting some of these details wrong. Rather, I'm trying to give you a sense of how we interrogate our models. So remember, as I said, we can't do much to evaluate our models externally. So that requires this kind of internal validation. Well, I will say there's something about making forecasts. You can lose, but you can't win. What I mean is we do this. If Biden gets 60% of the vote, we lost. I mean, look at our interval, right? If Biden gets 50% of the vote, then we lost. Well, of course, we can say, hey, unlikely things happen. It fell outside the 95% interval. What can you do? Like, you bad luck. I mean, we can say that and it might be true, but it's, you don't really want that to happen, right? It should only happen 5% of the time. So one problem with forecasting is even if everything you do is completely right and your model is correct and your data come from God, 5% of the time, your 95% interval won't contain the value. So if I do 100 high-profile forecasts, I just do one and I look bad. Well, if I do 100 and I do one that looks bad, then I can say the other 19 were good. If I do 100 and 20 and 5 look bad, I can say the other 95 look good, et cetera. But remember, I don't have 100 elections. Mm-hmm. So I could do one and just get bad luck, what can you say? So, but then the flip side is, if it's right, suppose Biden gets 54.3% of the vote. Do I get to like, preen 54.3? That's what we said. Or forget 50. I mean, you might not like to look at the popular vote. Okay. Let's suppose it's the electoral vote. Suppose, setting aside those two states where they count them differently, suppose Biden gets exactly 350 electoral votes. We say we predicted correctly. No, that's ridiculous. Our prediction is probabilistic. We think, sure, we maybe think 350 is the most likely outcome. We have a distribution. So we think the most likely outcomes, there's discreteness having to do with the fact that there are large states. So certain outcomes are more likely than others. The point is, any of these things would be consistent with our model. So first, even if we think we're wonderful, we would not expect our estimate to be correct. Second, if it happened to come out just where we guessed, we should not get extra credit for getting it just right. It doesn't work that way. Like, what if we predict 49 out of 50 states correct? Do we get to brag? No, we don't brag we pick 49 out of 50 states correct, because in expectation, we think we'll miss a few states. Because if you go to the map of the states, there are some toss-up states, the ones that are uncertain. Iowa, Ohio, Georgia. Basically, we think that we would only get approximately 1.5 of Iowa and Ohio and Georgia correct. Texas, there aren't as many close states as there sometimes are, but the point is we wouldn't expect that. So you can't win, but you can lose. Forecasting is kind of not a great game to be in if your reputation is what you care about. Okay, so here's an example of how we lost. So here's a graph. They didn't send us this graph, but my collaborator made this graph. I'm just trying to make the window so it's readable here. Okay. We retrofitted our model. We retrofitted our model to 3 past elections: 2008, 2012, and 2016. These are elections where we had a lot of poll data. And then for each state, we computed its 95% predictive interval based on retrofitting, right, to the model, just using the data in that year. And then we isolated in red the states where the 95% interval excluded the true value. So with 50 states, you should expect to have 2.5 that fall outside the 50% interval, right? That's 0.05 times 50 is 2.5%, 2.5. Okay. But as you see, we have more than 2.5 states per election fell outside the interval. Now, what's interesting is it's not always the same states. Sometimes it's the same states and sometimes it isn't. It's not always favoring one party or the other. In 2016, the mispredictions mostly favored, our model mostly underpredicted Trump, but not in California. In 2012, it was all over. In 2008, it was kind of mixed. So the point is that our 95% intervals are too short because they're not containing the truth. So but we can't be sure. But remember, I said that we only have a few past elections and they're not independent. They're not independent, but given that the errors are not all happening in the same direction, it is kind of independent evidence that there's a problem in our model. So I do think that our tails are too short. Unusual things do happen in politics. You do have really big polling errors, and we did not account for that. Our model. So really, we should go back and use a longer tail distribution of errors. And we didn't do that just because when you add one thing, again, to take the analogy of building a car or a bridge, when you add one thing to your machine, it can break other things. And so we did not, right now, this close to the election, we decided that this was a fairly small error. We don't fully trust the tails of our intervals. I don't really think our 95% intervals, I think we're overstating our certainty a little bit. We're being overconfident in our predictions. It didn't seem like a huge deal, and we weren't ready to start taking our model apart and changing it 2 weeks before the election, but we're going to look at in the future. How did people discover this? Because our code is open source. It's not 100% open source. Part of the stuff, I don't know the full detail of The Economist. They didn't want people to completely reproduce our 2020 forecast for free. So the old data is completely open source. The new data, the code, for 2020, most of the code is open source, but certain aspects of the fundamentals-based model are closed, actually. Kind of complicated. Anyway, we had enough open source that the hive mind was able to find this problem for us. Okay, now I want to tell you a different story. And this is a story about problems with the 538 election forecast. And I'm going to open an R window. So 538.com is as I said, they're an organization that forecasts elections, and they also do sports forecasting, and they do a lot of things. They're like I guess, kind of a sports and politics news site. They have done probabilistic election forecasts in the past. They have a very good reputation because in 2016, they gave Donald Trump something like a 2/3 chance they gave Hillary Clinton something like a 2/3 chance of winning the election. Of course, Hillary Clinton lost the Electoral College, but it was good for 538's reputation because their probability of Clinton winning was lower than everybody else's. Because really in 2016, almost all the evidence seemed to favor Clinton. It would have been hard to make a forecast. According to reports, even the Trump team did not think that they were going to win the election until the election actually happened. But 538 has a very good reputation because they were not overconfident back in 2016. Then in 2020, they released a forecast a couple months after we released ours. And people noticed some funny things about their forecast. So one thing was that the state prediction intervals in their forecasts were very wide. So for example, when we were saying that we thought Biden would get between something like 46% and 56% of the vote in Florida, they were saying Biden would get somewhere between 42% and 60%. And we just never really thought, our model never thought that Biden was going to get 60% in Florida, and we never thought that Biden would only get 42% in Florida. Their interval was much wider than ours. Another example was that we have the probability of Biden winning Alabama as less than 1%. And they have the probability of Biden winning Alabama as being 2%. So they have unusual outcomes they assign higher probability to. And in fact, if you go to their page, they say Biden is very likely to win California, but they have a possibility. They think it's possible that Trump will win California. I don't think I would give Trump winning California much lower probability. They also think that Biden might win California by 60 points, which means he would get 80% of the vote and Trump would get 20%. I don't think Biden is going to get 79.4% of the vote in California. I just don't think these extreme points are possible. I mean, they're mathematically possible. They're mathematically possible in the same sense that the Jets could win the Super Bowl this year, but I don't think it's going to happen. No. So let's kind of pin that to the wall here. The idea being that they are consciously being what they call conservative in their forecasts. They're making their intervals wider because they don't want to miss some weird event like for example, Biden getting 80% of the vote in California or Trump winning California. They want to allow for that in their model. And so now what does that do to you? So I didn't know, it was very difficult to understand this, but then one day somebody commented on our blog and they said, hey, because their code is not open. So nobody knows what they're actually doing. They have a description, but it's a trade secret. So he said, hey, someone commented and said, hey, the simulations from the 538 model are online. You can download them. So I downloaded them and I read them into R. And I will do a screen share and we'll do some R. R is our, okay. It's our open source statistics platform. Okay, so I'm not going to go through each line of code, but I'll just say that there was a file, a JSON file. It was called sim.maps.json. And I read in the JSON file and I did some pre-processing of the file. And I'm going to copy and paste the code. Ooh. Okay. And there was a weird thing. They had this map. They sometimes release maps showing possible election outcomes. And they had a map saying one possible election outcome was that Biden wins 59 states and Trump wins one state. Now, I want you to think for a second. If Trump were to win just one state, what would it be? Well, they had New Jersey. Okay, well, just, anything can happen, right? Jets might win the Super Bowl, right? So I created this condition. I said, well, wait, I should, can I, you know what I should do? You know what I'm actually going to do? I'm actually going to, well, sorry. Okay. I have old code, so I'm not typing it in. So I decided to condition on Trump winning New Jersey. And what I'm giving you now is Trump's probability of winning each state if he wins New Jersey. So it says that if Trump wins New Jersey, he has a 58% chance of winning Alaska, an 80% chance of winning Alabama, an 89% chance of winning Arkansas. There's something funny about an 100% chance of winning New Jersey, right, by definition. There's something funny about this, which is I think if Trump won New Jersey, he would win like 47 states. Like so there's something that was not right. And I noticed Alaska is the first state here. So I thought I'd look at Alaska. So I'm going to print here first the probability Trump wins Alaska if he wins New Jersey, 58%. What about the probability Trump wins Alaska if Biden wins New Jersey? 80%. So this says that Trump's probability of winning Alaska is higher if Biden's almost certainly going to win New Jersey. So basically it says Trump has an 80% chance of winning in Alaska, but if he were to win New Jersey, he's supposed to get 40% of the vote in New Jersey. So if he wins New Jersey, it would be a 10% shift in his favor. Then his chance of winning Alaska would go down. So I didn't understand that. So I made a graph. Sorry. I'm not used to this manipulating while I'm online here. Okay. Okay, so here, 538 produced 40,000 simulation draws. These are the possible outcomes of the election in New Jersey and Alaska. I shaded in if he wins New Jersey. There's essentially a zero correlation between how well he does in New Jersey and how well he does in Alaska. But there's a funny thing about the model, which is that if he happens to win New Jersey, he's actually doing a little worse in Alaska. It's kind of a weird thing. Now it's hard to read this graph because of all the dots in the middle. So I just took 1,000 random dots out of the 4,000. Now you can kind of see it better. Now you're missing some extreme events, but they're very unlikely anyway. So it's kind of, I was trying to understand how this is. Like, why? So I think the reasoning is pretty simple. The reasoning is New Jersey and Alaska are kind of completely different states. So your uncertainty about New Jersey should be independent of your uncertainty about Alaska. But I don't think that's actually correct, because my understanding of voting and politics is that when there's that swings can happen at the national level. If Trump does much better than expected in New Jersey, it's not that something special happened in New Jersey for him or even in the Northeast. It's probably what we call in political science a valence issue. Like people decided that he was showing excellent leadership with the coronavirus, or Joe Biden was looking looking very incompetent, or said something that people didn't like whatever it is. It's not that it's impossible to swing just one state, but in general, we would expect to see the states swinging together. So I decided to look at some other states. I looked at New Jersey and Pennsylvania. And I'm going to end this in a moment and just summarize things. Here are New Jersey and Pennsylvania. So New Jersey and Pennsylvania are positively correlated. I don't think the uncertainties in them are positively correlated. So if he wins New Jersey, then it's likely, although there's still this funny thing that if he wins New Jersey, it goes down here. And I'll get back to that. I looked at Alabama and Mississippi. They have a super high correlation, which, of course makes sense. You would expect that they'd be correlated. Wisconsin, Pennsylvania. Oh, and then I looked, for reasons I won't get into, right now, I looked at Washington and Mississippi, Washington being Washington State, not Washington, D.C. And we see a negative correlation, which I think is kind of weird. We had some discussion on the blog about why this is happening, and there's some error term in their model in this 538 simulation that acts kind of like a seesaw. And when one candidate does better in more Democratic leaning states, they end up doing worse in Republican leaning states. And so you get this behavior. But I don't really think this is quite right. I think that if you told me that Trump won Washington, I don't think that means that would be indication that he did really awesome in Mississippi because he managed to appeal to liberals. I think what would happen is it would really represent a national swing. So I think what occurred, to get back to this forecast, is that forecasts get created by putting together lots of different features in the model. So I told you about our time series model and our different error terms. The 538, they have their own method. It's not fully described. The code isn't open, but they're basically also adding uncertainty terms for their forecast. Not through latent variables the way we do, though. I think they're doing it by kind of adding errors, independent errors of different sorts. And I guess they somehow don't seem to have a very large national error term, but they do have these negatively correlated state errors. I think negatively correlated error could be appropriate in certain situations. It's kind of a zero, to the extent that it's like a zero-sum game. You get more votes in one place and you lose them somewhere else. But as I said, I don't really think that the polling errors and the changes in public opinion quite work that way. I think there's some of that, but I think there's also a national swing. Now, I want to get back to this conservatism thing. If you have 50 states, so this is some math, okay? If I have a probability distribution on 50 states and the 50 states are independent, and then I want to make a forecast for the national average vote or the electoral vote. The electoral college vote is a nonlinear transformation of the state votes, but it's still a form of average. What's going to happen is you're averaging 50 independent numbers and you're going to get a bit of cancellation. You get a little what we call the law of large numbers in statistics. An average is less variable than the individual components. Now it's complicated because the electoral college and because it's a weighted average, you're not averaging 50 numbers. If you're just averaging 50 numbers, you divide the standard deviation by square root of 50. It's not quite that because some states count more than others, but you get a kind of cancellation, a law of large numbers effect. As a result, to get a reasonably uncertain national average prediction, you need to have very large uncertainties in your individual states. Now, you can avoid that, and we avoided that in our forecast by having very large positive correlations between the states. So if your state uncertainties have large positive correlations, then the average of those 50 numbers, or the weighted average of those 50 numbers, is not much less variable than the individual numbers themselves because they're positively correlated. You don't get a kind of law of averages thing happening. In our model, if Trump does better in New Jersey, he's probably also doing better in Mississippi and everywhere else. In this 538 model, they have some zero correlations and some negative correlations. As a result, for them to get the uncertainty that they desire for the National Electoral College forecast, they need to have really wide uncertainties in the state forecast. Conversely, if they were to make reasonable uncertainties for the state forecasts, with their low correlations, they would end up getting a national forecast that's hyper precise, that no one would trust. So what I'm getting at is that our exploration of their those simulations that they gave us insight into why they had such wide uncertainties for the individual states, for Florida and all the other states. So we were able to kind of deduce. So what I'm saying is that when they had a super wide interval for Florida, I don't think it's because they said, hey, we better allow for the possibility that Biden will only get 42% of the vote in Florida because, hey, well, who knows, it might happen. The same with that ridiculous interval for California. It's not that. It's that they needed that in order to get the national uncertainty where they wanted it. So it's these forecasts have a lot of moving parts. And it might well be that the 538 national forecast, it could be fine. Indeed, as I said, like I could see the case that our intervals are too narrow. But I do think that next time they could do better by kind of working on their correlations and their uncertainties. That way they could get state level forecasts that made a little bit more sense. But I certainly, I don't want the message to be that like they're so horrible and we're so great. The message that I want to send is that no forecast is perfect. You don't want to forecast a single number. Even if your only goal is to estimate the electoral college vote, you should forecast all 50 states. If you can do it, forecast the outcome in all 3,000 counties of the country, forecast things over time, make your forecasts as rich as they can possibly be. Give yourself ways to fail because you'd rather fail sooner than later. The same with that bridge. If it's going to fail, you want it to fail in little places where it can be fixed. You don't want to wait until the whole bridge cracks and falls. So good luck in your engineering careers. I hope you can apply these principles.
Thank you very much. You know, this is just fascinating, and I can understand why you get caught up in it because it's just so much going on. Anyhow, I know that you have to go. Thank you very much, and I really appreciate you taking the time to explain this all to us.
Okay, well, I hope the class goes well.
It shall, and I thank you very much.